Hello children, welcome back to my channel. In the last class we have stopped up to 14 number question, and in this video we'll start from the question number 15. So what it says, A, B and C are the three forces each of magnitude 4 Newton acting in the same plane of a paper as shown in the figure, and the point O lies in the same plane. Here is the three forces A, B, C, and each of these forces is 4 Newton. It means for A 4 Newton, for B 4 Newton, and C for a 4 Newton. And the point O lies in the same plane. Okay, so what is the next question for this? Which force has the least moment about O? And give a reason. So obviously C will be the least moment. Why? Because the distance between this point O and this force is less. So that's why C has the least moment. Next one is, which force has the greatest moment about O? Give reason. So obviously A will be the greatest moment. Give reason, that is the maximum distance from the point O. And force. Name the force producing clockwise and anti-clockwise. That A produce a clockwise, B produce a clockwise, and the C only produce the anti-clockwise moment. Next, fourth question in that, what is the resultant torque about the point O? So here we have to do calculation. Okay. Now, this is for the A, this is for the B, this is for the C, and in all these three, 4 is a common. I mean 4 force is a common, and 0.9 is this distance. For this 0.8 is the distance, and for the last one is 0.6. And for the A is a clockwise direction, that's why given a negative sign. For the B also it gives a clockwise direction, for that also it gives a negative sign here. And this C only it gives the anti-clockwise direction, for that here is the positive sign. So after doing the all calculation, the final answer will be minus 4.4, and it gives the clockwise direction. Why? Because the sign shows the minus. The next question, number 16, for this diagram is in the next page. Now let me read the question. The adjacent diagram shows a heavy roller with its axle at a O. So here is the diagram, and its axle is O. It's a heavy roller. And what says, which is to be raised on a pavement xy, where it has to be raised? It has to be raised here. Next, if there is a friction between the roller and pavement, show by an arrow on the diagram the point of application and the direction of the force to be applied if pivoted at O. Now will it go up? So if the force is applied in this direction, it will go up. Okay, now let us go to the next question. 17th question. A body is acted upon by two forces, each of magnitude F, but in opposite direction. State the effect of the forces if. So first understand the question. A body is acted upon by two forces, each of a magnitude of F. So here is body is acted upon by two forces. Each of the forces F, but in opposite direction. So both forces are in a opposite direction. Okay, and then what says, state the effect of the force if both force act at the same point of the body. So what it means, I'll take one diagram. Here is the one body, it's a pivoted point. Here the two forces which is acting at the same point. If it is acting at the same point, means the net force will be 0. Here this force gets subtract, and the net force we will get, that is 0. So there will be no movement in this body. So what is the next question? So what is the answer you have to write? Resultant force acting on the body will be 0, that is F minus F 0. So what is the second one? The force acts at the two different points of the body at a separation. So here is the one body, here is the separation is R. The one force is acting here and another force is acting in this direction. Obviously both are in a opposite direction and the separation is R. So in this case what happens? The force tends to rotate the body between two forces about the midpoint. So through this midpoint the body starts to rotate. So the moment of force will be F into R, that is distance. Draw a neat label diagram to show the direction of two forces acting on a body to produce rotation in it. Also make the point O about which the rotation takes place. So what is in saying, draw a neat label diagram. Here the picture is drawn already, to show that the direction of two forces acting on a body to produce a rotation. See, the forces must be in a opposite direction, then only the rotation causes. Otherwise, if you applied the same direction, means there will be no rotation. So the force must be applied in the opposite direction, remember here. And also make the point O. So here is the point O, which the body it will start to rotate. Okay. At A and B, two forces each of magnitude F are applied, which are equal and opposite forces. It is very important. By observing the above figure, it is clearly that two forces rotating in which direction? In which direction it is? It is anti-clockwise direction. It is rotating in anti-clockwise direction. 19th question. What do you understand by the term couple? State its effect. Give two examples in our day-to-day life where couple is applied to turn a body. So, what is you understand by the term couple? Couple means here there will be two forces, a pair of forces. Okay. So, what is the definition of couple? Two forces not acting along the same line, which are equal and opposite parallel forces, form a couple. So here will be two forces will be there. Just erase everything. So here will be two forces will be there, and which are equal and opposite parallel forces. Equal, the two forces are equal and opposite, and these are the parallel. Okay, and it forms the couple. And one more definition here, it is two equal and opposite parallel forces not acting along the same line forms a couple also. It should not acting in the same line. For example, if the force is here and another opposite force, it should not be here. It must be acting in the parallel line like this. It should not act in the same line. Either you can write this definition or this definition. So, and for this, state its effect. A couple is always required to produce a rotation. So, with the help of these two forces, the always couple it produce the rotation. Example, turning a key in the hole of the lock and turning the steering wheel of a car. Next question, 20th question. Prove that moment of couple is equals to 4 into couple arm. So first draw the diagram here. Again see here that two forces acting in opposite and parallel are there. The moment of force, and here the name is given A. Here is A, B, two magnitude force F, and the midpoint is O, and from here to here the distance is D. Okay, and moment of force F at end A, that is F into OA. From here to here distance, that is OA. Now next one is moment of force F at B, that is F into OB. Now total moment, we have to do addition here, this total moment, that is F into OA plus F into OB. That we will get here. As we know that OA plus OB, that is D. So F into D is the total moment of couple. Okay, actually I forgot to read the question number 20. So before the 21, I must read the 20th question. Then only you can understand that prove that moment of couple. But anyway, I'll read it now. So what is define the moment of couple? Write its S in it. So what it says, the moment of couple is equal to the product of the both forces. The both forces will be equal, and the perpendicular distance between the two forces. Perpendicular distance between the two forces means this is only. This is the perpendicular distance between these two force. And the SI unit for this is obviously Newton into meter. 22nd question. What do you mean by equilibrium of a body? What do you mean by equilibrium of body? So what it definition says, when a number of forces, here is the number of forces acting on a body produce no change in its state of a rest or of a linear or rotational motion. See, there is one rigid body, a number of forces actually applying on that body, but there is no changes in that body. It is at that state of rest only. So there is no linear motion, there is no rotational motion. So the body is said to be in equilibrium. Next question. State the condition when a body is in a static or a dynamic equilibrium. Give one example each of the static and dynamic equilibrium. So actually, in equilibrium of a body, there is a two kinds of equilibrium of a body. One is a static, one is the dynamic equilibrium. So what is the static equilibrium defines? Static equilibrium is defined as when a body remains in the state of rest under the influence of several forces. So under the numbers of forces, the body, if it is remains at a rest only, the body is said to be static equilibrium. For example, a book lying on the table is in static equilibrium. Yes. Okay, that is a example for that. Next one is dynamic equilibrium. Is defined as when a body remains in the same motion under the influence of several forces, the body is said to be dynamic equilibrium. For example, here we'll take a raindrop. Okay, see, raindrop which is coming from the cloud and it is going to reach the earth. Okay, so it is coming, so while coming it to the earth, it will be it will be friction with the air layer also, but still it comes with the constant velocity and it will reach the earth. So this is the dynamic equilibrium. So there will be, see here it is coming in the downward, that is one force, and there will be a buoyant force will be there, and this friction force will be there, but still it comes with a constant velocity. 24th question. State two conditions for a body acted upon by a several forces to be in a equilibrium. So there are two conditions. The resultant of all the forces acting on a body must be 0. Then only it will be in the equilibrium. And the algebraic sum of the moment about the point of rotation of all the forces acting on the body should be 0. 25th question. State the principle of moment. Name one device based on it. So the definition for that. According to the principle of moment, if the algebraic sum of a moment about the axis of rotation of all the forces acting on the body is 0. So in the next question only we will discuss by taking one example, then that time you will understand this principle. Then the body is said to be in an equilibrium. A beam balance is the device which works on the principle of a moment. 26th question. Describe a simple experiment to verify the principle of moment if you are supplied with the meter rule, a fulcrum and two spring with slotted weights. Suspend a meter rule horizontally from a fixed support by means of strong thread at a point O as shown in the figure. So here is the figure. Now look at this picture. Here is the ruler and which is fixed with the support by means of this strong thread at a point O. Now actually this ruler is horizontal. Okay, now what to do next? Next is, now with the some slotted weights W and W2, suspend two springs balance on either side of the thread. Okay, see now imagine this is a without this spring. That time this ruler is horizontal. Now what to do next? We have to suspend two weights. One is W1, W2. W1 is at A side and W2 is at B side. She forgot to write here A and B. Okay, W1 is at A side, W2 at a B side with the help of these spring. Okay, now what happens next after suspending this one? Suspended to two spring on either side of the thread, the meter rule may tilt to one side. Now adjust the two spring balance distance from the support by keeping one at A and other at B, so the scale became a horizontal. So now what happened after suspending these two weights? The scale started to tilt. So but earlier it was a horizontal. Now what to do? We have to adjust the distance. Either you can take this spring at this side or this side, or this B side, this W2, at least you take I mean up to O only, not more than that. Either you can move this side. So what you have to do, you just adjust the distance, so this ruler must become a horizontal. Okay, so after adjusting, imagine this ruler become a horizontal now. So what next? Able to take this also. Okay, now let W1 at a distance OA-L1 be the weight of the suspend on the right side of the thread from the spring balance at A, while W2 at a distance OB-L2 be the weight of suspended on the left side of the thread from the spring balance at B. Again go back to the picture. So this is the right side and this is the left side. From here O to A, the distance is L1. From O to B, the distance is L2. Okay. Now again go back to the here. Now the weight W1 tends to turn the scale clockwise, whereas W2 tends to turn the scale anti-clockwise. So here this W1 tends to clockwise and this is anti-clockwise. Clockwise movement, for that W1 into L2, anti-clockwise movement, that is W2 into L2. So obviously this is a force here and this is, as you know, in that expression only, force into distance. So here is the W1 into L1 for the clockwise, and for anti-clockwise W2 into L2 distance. Next, in equilibrium, now it is become equilibrium actually. Why? Because the meter becomes a horizontal. In equilibrium, when the scale is horizontal, it is found that clockwise moment must be equals to anti-clockwise moment. So what the principle of moment says, the clockwise moment, it must be equals to the anti-clockwise moment. So in the state of principle of moment only it is there. According to the principle of moment, if the algebraic sum of the moment about the axis of rotation of all the forces acting in the body, it must be 0, then only the body is said to be equilibrium. So this is the principle of moment. Okay, I think it's clear to you all. Now I'll stop the video here itself. So next question and numericals I'll start in the next video. Thank you.